The 2003 National Electrical Estimator is an older program that hasn't been updated since 2003. Therefore, it may not be the best or easiest solution available today. Several more current estimating programs exist that could be more suitable. One such program is RSMeans Estimating Solutions. RSMeans provides access to a database of historical pricing and construction costs, offering a broad perspective on project expenses. Another option is Means Electrical Estimator, which specializes in the electrical industry, offering up-to-date labor and material costs. This targeted approach can provide more accurate and relevant estimates for electrical projects. Sage Estimating is a cloud-based software that includes features like bid management, takeoff, and collaboration. The cloud-based nature enables accessibility from various locations and promotes teamwork. Planswift Electrical integrates with AutoCAD and other design software for accurate takeoffs and estimating. This integration streamlines the process and reduces potential errors. To acquire estimating resources in the Orlando area, several bookstores are available. Firstly, there is Barnes Noble at the University of Central Florida bookstore. Secondly, there is Books A Million in Kissimmee. Thirdly, Powell's Books at City Walk is another option to consider. Fourthly, half-price books may have used copies of the estimator or similar resources. It is recommended to call these stores ahead of time or check the store websites for availability before visiting, as stock can vary. Considering shipping and duty implications, purchasing items online for shipment to Canada may incur import duties and taxes. The precise costs will depend on the item's value and the chosen shipping method. To understand electrical circuits, it's important to know about voltage, amperage, and resistance. Voltage, measured in volts, is the electrical potential difference that drives the flow of electrical current. Amperage, measured in amps, is the rate of flow of electrical charge. Resistance, measured in ohms, opposes the flow of electrical current. Ohm's law describes the relationship between these three quantities: voltage equals current times resistance, or volts equals amps times ohms. Electrical safety is paramount when working with electrical circuits. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Ground fault circuit interrupters, or GFCIs, are designed to detect even small imbalances in current flow, quickly interrupting the circuit to prevent electrical shock. Arc fault circuit interrupters, or RSIs, are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. Proper wiring techniques are essential for electrical safety. Use appropriately sized conductors for the intended current load. Make sure all connections are tight and secure. Protect conductors from physical damage. Follow the National Electrical Code, or NEC, guidelines for wiring methods and installations. The NEC is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Familiarity with the NEC is essential for anyone working with electrical systems. NEC Table 310.15 provides ampacity ratings for conductors, which are the maximum currents that conductors can carry safely under specific conditions. These ratings depend on the conductor material, size, insulation type, and ambient temperature. Dating factors must be applied when conductors are installed in conduit or in close proximity to each other, as this can increase the temperature of the conductors and reduce their ampacity. NEC Article 250 covers grounding and bonding requirements. Grounding provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse. Bonding connects non-current carrying metal parts together to create an equipotential plane, which minimizes the risk of electrical shock. NEC Article 300 covers general wiring requirements. This article addresses topics such as wiring methods, conductor identification, and protection against physical damage. NEC Article 400 covers flexible cords and cables. Flexible cords and cables are commonly used for portable appliances and equipment. This article specifies the types of cords and cables that are permitted for various applications, as well as the requirements for their installation and use. NEC Article 430 covers motors and motor circuits. Motors are a significant load in many electrical systems. This article provides requirements for motor circuit protection, motor controllers, and motor disconnecting means. The electrical calculations are essential for designing and installing electrical systems. These calculations ensure that the system is safe, reliable, and efficient. Some common electrical calculations include voltage drop calculations, conductor sizing calculations, and overcurrent protection calculations. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Conductor sizing calculations determine the appropriate size of conductors for a given load. The size of the conductor must be sufficient to carry the load current without exceeding the conductor's ampacity rating. Overcurrent protection calculations determine the appropriate size of circuit breakers or fuses to protect circuits from overloads and short circuits. Short circuit calculations determine the magnitude of fault current that can flow in a circuit under short circuit conditions. This information is used to select overcurrent protection devices with adequate interrupting ratings. Electrical drawings are used to represent electrical systems graphically. These drawings typically include single-line diagrams which show the major components of the system and their interconnections, and wiring diagrams which show the detailed wiring connections. Electrical symbols are used to represent electrical components on drawings. These symbols are standardized to ensure that drawings can be easily understood by different people. Understanding electrical components is essential for working with electrical systems. Some common electrical components include resistors, capacitors, inductors, transformers, and diodes. Resistors oppose the flow of electrical current. Capacitors store electrical energy in an electric field. Inductors store electrical energy in a magnetic field. Transformers transfer electrical energy from one circuit to another. Diodes allow current to flow in only one direction. The electrical troubleshooting is the process of identifying and repairing problems in electrical systems. Troubleshooting typically involves using test equipment, such as multimeters and circuit tracers, to measure voltage, current, and resistance. Safe work practices are essential when working with electricity. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as safety glasses and rubber gloves. Follow lockout/tagout procedures to prevent accidental energization of circuits. Never work alone on electrical systems. Understanding the NEC is crucial for ensuring electrical safety and compliance. NEC 110.3 covers examination, identification, installation, and use of equipment. It states that equipment must be suitable for the intended use and installed according to the manufacturer's instructions. NEC 110.12 covers mechanical execution of work. It requires that electrical work be performed in a neat and workmanlike manner. NEC 210.8 covers ground fault circuit interrupter protection for personnel. It requires GFCIs in dwelling units in areas such as bathrooms, kitchens, and outdoors. NEC 210.12 covers arc fault circuit interrupter protection. It requires FSIs to protect branch circuits supplying dwelling unit living areas. NEC 250.4 covers general requirements for grounding and bonding. It emphasizes the importance of creating a low impedance path for fault current to flow back to the source. NEC 300.11 covers securing and supporting wiring methods. It requires that wiring be securely supported to prevent damage and maintain proper spacing. NEC 310.15 provides ampacity ratings for conductors. It is essential to consult this table to ensure that conductors are sized appropriately for the intended load. NEC 408.3 covers arrangement of circuit breakers and switches and panel boards. It requires that circuit breakers and switches be arranged in a neat and orderly manner. NEC 430.52 covers motor circuit protection. It provides requirements for overcurrent protection of motor circuits. NEC 440 covers air conditioning and refrigeration equipment. It provides specific requirements for the installation and wiring of this type of equipment. NEC 517 covers healthcare facilities. It provides additional requirements for electrical systems in healthcare facilities to ensure patient safety. NEC 547 covers agricultural buildings. It provides specific requirements for electrical systems in agricultural buildings due to the presence of dust, moisture, and corrosive materials. NEC 600 covers electric signs and outline lighting. It provides requirements for the installation and wiring of electric signs and outline lighting. NEC 625 covers electric vehicle charging systems. It provides requirements for the installation and wiring of electric vehicle charging systems. NEC 680 covers swimming pools, fountains, and similar locations. It provides specific requirements for electrical systems in these locations to prevent electrical shock hazards. Furthermore, working safely with electricity necessitates several precautions. Firstly, always assume that circuits are energized until proven otherwise. Secondly, use insulated tools and equipment. Thirdly, avoid working in wet or damp conditions. Fourthly, never bypass safety devices. Fifthly, be aware of your surroundings and potential hazards. Sixthly, use a multimeter to verify that circuits are de-energized before working on them. Seventhly, follow lockout/tag-up procedures to prevent accidental energization. Eighthly, seek help from a qualified electrician if you are not comfortable working on electrical systems. The appropriate size of overcurrent protection is determined by the ampacity of the conductors being protected and the type of load being served. The overcurrent protection device should be sized to protect the conductors from overload and short-circuit conditions, but it should not be so large that it allows excessive current to flow through the conductors. For example, a 14 American wire gauge copper conductor with type TW insulation has an ampacity of 15 amps according to NEC table 310.15. Therefore, it should be protected by a 15 amp circuit breaker or fuse. A 12 American wire gauge copper conductor with type TW insulation has an ampacity of 20 amps. Therefore, it should be protected by a 20 amp circuit breaker or fuse. A 10 American wire gauge copper conductor with type TW insulation has an ampacity of 30 amps. Therefore, it should be protected by a 30 amp circuit breaker or fuse. When sizing overcurrent protection for motor circuits, the NEC allows for higher overcurrent protection ratings to accommodate the motors in rush current during starting. The specific overcurrent protection rating will depend on the motor's horsepower, voltage, and code letter. When working with electrical systems, it is essential to have a basic understanding of electrical theory. Electrical theory provides the foundation for understanding how electrical circuits work and how to troubleshoot problems. Some key concepts in electrical theory include Ohm's law, Kirchhoff's laws, and the principles of series and parallel circuits. Ohm's law states that voltage equals current times resistance. Kirchhoff's current law states that the sum of the currents entering a node is equal to the sum of the currents leaving the node. Kirchhoff's voltage law states that the sum of the voltages around a closed loop is equal to 0. In a series circuit, the current is the same through all components, and the voltage is divided among the components. In a parallel circuit, the voltage is the same across all components, and the current is divided among the components. Understanding these basic concepts will help you to troubleshoot electrical problems more effectively. The National Electrical Code, or NEC, is updated every 3 years. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical work is compliant with current standards. The NEC is available for purchase from the National Fire Protection Association, or NFPA. Many local jurisdictions also adopt the NEC as part of their building codes. In addition to the NEC, there are other electrical codes and standards that may be applicable to your work. These codes and standards may be developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of these codes and standards and to comply with them as required. Continuing education is essential for electricians and other electrical professionals. Electrical technology is constantly evolving, and it is important to stay up to date with the latest advancements. There are many opportunities for continuing education, such as courses, seminars, and workshops. Many trade schools and community colleges offer electrical training programs. Online resources can also be a valuable source of information. Furthermore, grounding electrode conductors are used to connect the grounding electrode to the electrical system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. Bonding jumpers are used to connect non-current carrying metal parts together to create an equipotential plane. The size of the bonding jumpers is determined by the size of the circuit conductors, as specified in NEC Table 250.102. Equipment grounding conductors are used to connect the non-current carrying metal parts of equipment to the grounding system. The size of the equipment grounding conductors is determined by the size of the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning or other transient events. SPD are typically installed at the service entrance and at downstream panels to provide comprehensive surge protection. A single line diagram is a simplified representation of an electrical system that shows the major components and their interconnections. Single line diagrams are used for planning, design, and troubleshooting of electrical systems. A three-line diagram is a more detailed representation of an electrical system that shows all three phases of the electrical power supply. Three-line diagrams are used for detailed design and analysis of electrical systems. A wiring diagram shows the detailed wiring connections between electrical components. Wiring diagrams are used for installation and troubleshooting of electrical systems. Electrical symbols are used to represent electrical components on drawings. It is important to be familiar with these symbols in order to understand electrical drawings. Electricians need to understand the different types of electrical meters used to measure voltage, current, resistance, and other electrical parameters. Multimeters are versatile instruments that can measure voltage, current, and resistance. Clamp-on ammeters are used to measure current without interrupting the circuit. Insulation resistance testers, or megers, are used to measure the insulation resistance of conductors and equipment. Circuit tracers are used to identify and trace electrical circuits. Power quality analyzers are used to measure and analyze the quality of electrical power. This information can be used to identify incorrect power quality problems. Overall, thorough knowledge and regular updates on electrical codes, best practices, and safety measures are of utmost importance for individuals working with electrical systems.